Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, in order for a series to converge, the limit of this thing here, the limit of an as n tends to infinity must be 0 in order for it to converge. So we should check that this thing will the limit will be 0. So imagine this thing here as 1 over n. So as n moves from 1 to infinity, you are adding a positive small amount to the denominator. Well, you as n moves from 1 to infinity, you are adding a small amount, and this thing here is just going to get bigger and bigger and bigger. So you're going to have 1 divided by something by the denominator, which keeps on getting bigger and bigger and bigger. So the limit of an as n tends to infinity will be 0. Okay, it will be 0. If it's anything other than 0, let's say if it equals, let's say 7, then we can be 100% sure that it's going to diverge. But here it equals 0. When it equals 0, it could still diverge or it could converge. So we can't determine anything because it equals 0. Okay, so now we have to do something else. So that something else would be the direct comparison test. So visualize this thing here as 1 over n. So by writing like this, you can see that as n moves from 1 to infinity, you are actually adding a small amount to this each time. You are adding a small amount to the denominator. So hang on. So as n tends to as n moves from 1 to infinity, if you look at the denominator, you've got one thing plus another thing. This thing here will be positive because you keep on adding a small amount to it. It will be a small amount because it's 1 over, let's say 99. It is a small amount. You're adding a small amount to the denominator. Well, if you here if you look at the denominator, you've got one thing plus another thing. If you remove something from the denominator, if you remove a positive amount from the denominator, then what's left? If you remove this, then what's left? This thing here will be bigger or equal to this thing here. So it's like me giving you this. Let's say 1 over 10. If you hang on, let me say 8 plus 2. If you remove, excuse me, if you remove a small amount from the denominator, if you remove this, then you can actually say 1 over 8 will be bigger or equal to 1 over 10. So that's us doing this. We're removing this thing here. So we can actually say this thing is bigger or equal to this thing here. Well, this thing here, rewrite as this. This is a geometric series because this bubble here is less than 1. So this thing here is less than 1. So it's going to converge. So this thing here will converge. Well, this thing being bigger or equal to this thing will have no choice but also to converge. Okay, so our series here will converge. Well, here's an alternative. You could, well, it's not really an alternative. If you try it this way, here you've got one bubble plus another bubble. If you decided to remove this bubble, then you can say that this thing here will be bigger or equal to this whole thing here. So if you decided to remove this one as opposed to this, which we did earlier, if you remove this, it won't quite work because you will have this being bigger or equal to this. Now tidy this up, that will then become this. So now if you look at this, this will diverge. So you've got something that will diverge. This thing here will diverge. But this thing here being bigger or equal to our series here, well, our series here could still diverge or it could converge. So by you removing this, it won't serve any purpose. Okay, so you should remove this. So our series up here, this method would be it won't serve us. So our series here will converge. Okay.